folks, today I'm going to talk to you about section 8.1, solving systems of linear equations using addition, and this is for the 8.4 assignment in our module this week. So some of you had for Algebra 1 and we covered this, but the idea is that these solving systems by addition and multiplication in the next video, it's just another way to solve a system. We talked about substitution last week and graphing. Now, graphing's kind of a pain. I would have to solve both of these for y to get them in that nice slope-intercept form for easy graphs. And then I would have to kind of say a little prayer here that those were nice points of intersection so that I could actually find them on my graph. So if you have two variables, you're stuck graphing, right? So the idea with this addition method, and you'll also have heard it called elimination, is that we're just going to eliminate one of the variables. And the easiest way to do this is just to notice that I have opposites right here. If I were to take these two equations and combine like stuff, 4x minus 4x is a big 0. Over here I have 10y, positive 10y, and over here I have a negative 10. Boom, we just eliminated a variable with no effort at all. And if you divide both sides by 10, you get that y equals negative 1. And then you have to remember what you found was really just half a point, right? We found the y half of this point. And remember, it's the point of intersection. So how do I find the other half? You can go to either one of these equations and plug in your y. So I'm going to go to this one. 4 times x plus 8 times whatever y we got equals 20. And we're just going to do a little math here. 4x, this is a minus 8. And we're just going to add 8 to both sides. And then when we finally divide by 4, we get the second half of our point. And these, if we were to go through all the trouble to graph those two lines, they would intersect at that point 7, negative 1. Now, I do have students who question why we can just add those things together and get rid of a variable, and why do we know we can do that? And I'm just going to give you a quick example over here that if you know, and this has nothing to do with the problem, this is what I will call an aside. Alrighty, we're going to step aside here and just look at trusting how we can trust that this really works, that when we're just allowed to add all of them together. And I'm just going to do something that we know is true. 1 plus 2 is definitely equal to 3. And I'm going to go with 3 plus 4 is equal to 7. We know the top statement's true and we know the bottom statement's true. So if this is 3 and that is 7, it kind of makes sense that when we add them, that's 10. And then if we were to add these, 4 plus 6, we could see that we really do get things that are equal. That's what the equal sign is. If this side's equal to this side and this side's equal to this side, if you add them, you'll get the same thing. So hopefully that'll help you kind of realize why we're totally allowed to do that to get rid of a variable. Okay, let's try one more of these. And I mean it. I have just one more, and then I'm going to set you free here to go ahead and get on to the rest of your work. All right, so this one we've been asked to solve using addition. That means we're just going to combine the lines, like we just talked about why we're allowed to do that and how we know it works. But the problem is your equal signs and all your like stuff have to be lined up. And the problem is I have x by itself over here, and this one has x and y on the same side, and then the equal sign. So we are going to have to take this first equation here. I'll put it over here. And I'm going to subtract y from both sides. And the only reason I'm doing this is so that things will line up. And then over here, this makes 0. I've got 11. And now I've got, for this first equation, x over here, y over here, and 11. And I'll bring this one back down. So we rewrote the first one. so that we have everything lined up. The equal sign, the number, the constant, the y's, and the x's. And I think you can see right now we've already, let me fix this. Okay. And I think you can see when we get x and y on the same side and line up all the stuff, the equal sign, the constant, the y's, and the x's, that we already have opposites. We are ready to eliminate a variable, and it looks like it's the y's that are going to go. So let's go ahead and just add these. Combine all the like stuff. I'm getting a 30 over here. This totally makes 0, which is great because we've eliminated. And 1x plus 2x is 3x. And if we go ahead and solve for this, we get that x equals 10. What we found was the first half of the point of intersection. To find the second half, you can go back to either equation that you want and plug it in. I really do like the first one. So it says x equals 11 plus y. So our x is 10. So 10 equals 11, and the y we don't know, so I'm going to leave it as the variable. To get y by itself, to solve for y, we're going to minus 11 from both sides. This makes 0 and leaves us with just y, and this makes negative 1, so it looks like y equals negative 1. And if we were to go through the trouble to graph these, we would see that they intersect at the point 10, negative 1. Alrighty, folks, that's it for me.